by the interaction, for example, of hydroxyl ion with unsaturated lipid, and that process continues, and lipid peroxides are generated. Now, this process is probably quite important in atherosclerosis. Briefly describe what's shown here. So LDL is this major carrier of cholesterol. It enters the artery wall, but doesn't accumulate in itself. It has to be modified in some way, and it's actually oxidized to oxidized LDL, which can then be taken up by white cells. And these white cells become rather angry, producing cytokines that damage other cells, including the endothelial cell. Just to show you that that's happening here, this is from a human section of an artery. And what you see here in red, first of all, these are cells which are stained with something which is against oxidized LDL. And this one here, this parallel section, is from a section where the cells are stained, that is, the macrophages are stained, and they co-localize. So what's happening is this, and some of this is beneficial and some of it's harmful. Oxidized lipids, reactive oxygen species interact with cells. You get an expression of transcriptional factor NF-kappa B, which then goes into the cell and then stimulates a whole range of cellular processes, some of which are harmful and some of which are potentially beneficial. So pro-inflammatory response, cell adhesion, and then beneficial is the induction of antioxidants and heat shock proteins, which I'll mention in a little while. How is this process inhibited? Which there are some natural inhibitors and some which are present in the diet and some present within the body. So vitamin C and vitamin E, I'm sure you've all heard of, in the diet. Albumin and urates, these are produced endogenously. They're